Hola, niños, ¿cómo estamos? We're continuing our lessons with area. We've already learned how to find the area of a rectangle. Okay, it's really easy. You just multiply length times width, the length of one side times the length of another side. Today, we're going to be looking at how we can find the area of some other shapes, some kind of funny shapes. But before we do that, I just want to review a few things about rectangles because it's going to be important for us to know before we move on. Okay, here we have a rectangle with 8 inches. It is 8 inches long on one side and 3 inches long on another side. 8 inches long on the right side, 3 inches long on the bottom. Okay, one very important thing we need to remember about rectangles, and we talked about this a little bit in our Zoom session last week. Okay, it's very important to remember that the opposite sides of any rectangle, the opposite sides are equal, because you might have some missing information that we're going to need to figure out or fill in. So what I mean by that, if this side on the right is 8 inches, then what is the side on the left? It has to be the same, okay? Opposite sides of rectangles are equal. So if the side on the right measures 8 inches, it means the side on the left must also measure 8 inches, okay? So let me just write that in. So the bottom measures 3 inches. Well, what about the top? They are opposite sides, so they have to be equal. So if the bottom is 3 inches, the top must be 3 inches, right? So let's write that in. Okay, so that's just a basic review of an important property of rectangles. Any rectangle, it doesn't matter how big it is or small it is or long or anything. Every rectangle in the world, opposite sides are equal, right? 8 on the right side, so there's 8 on the left side. 3 on the bottom, so there's 3 on the top. A square, by the way, a square is a rectangle. It's just a special kind of rectangle. How is a square different from a rectangle? Because all of the sides are the same length. Okay, it's important to understand this idea that opposite sides are equal, and you're going to see why over the next couple of days. We're going to start to look at some shapes that are called composite figures, which are kind of funny looking shapes, and we're going to try to figure out how we can find the area of these shapes. Okay, so I created here what we call a composite figure. Okay, it does not match any shape that we know, right? It's not a rectangle, it's not a square, it's not a triangle, it's not a circle, etc. And our task is to find the area of this shape. First of all, you might notice that there's some missing numbers, right? We know the top side measures 8 feet, the left side measures 10 feet, the bottom 6 feet, and this little part measures 4 feet. We are missing this number here, and we're missing this number here. We might need to find those numbers. And that's why we did that little review of rectangles, right? We're going to need to know that opposite sides are equal so that we can figure out the missing numbers, if there's any missing numbers. Anyone have this is what I wish we were in class. Anyone have an idea of what we might do to this funny shape so that we can find the area? Because right now we have no idea how to find the area for a weird shape like this. We know that if we put in all those little tiles, right, those little fichas, if we tile it, if we make all those little squares, then we would just count the squares to find the area. And then we learned how to find the area of a rectangle, just multiplying length times width. But we have never learned how to find the area of a weird shape like this. So what do? Well, there's a really awesome trick that I'm going to show you right now. Basically, what we can do is we can just chop this shape into rectangles, right? We're going to take out our machete and we're going to chop, okay? Because we do know how to find the area of a rectangle. So as long as we have rectangles, we can find the area of each rectangle and then just add them up to get the area of the whole shape. So we have two options in this case. right? I'm gonna draw a line, okay? I could draw a line right here to chop this shape into two rectangles, or I could draw a line right here, okay? It doesn't matter, you could do either one. I'm gonna try this one. So let me get my drawing tool and let's change the color. Okay, so I'm gonna make a line right here, okay? Then we can say I have this one huge rectangle. We'll call this rectangle 1, okay? Maybe I can just put a little number in the corner, okay? This is rectangle 1, okay? And then this little rectangle here, we'll call rectangle 2, okay? So the area of a rectangle, all we need to do is multiply length times width. So let's look at the big rectangle first. I see that this side on the left measures 10 feet and this side on the bottom measures 6 feet. That's all the information I need. I don't need any more information. I'm not missing any information. We can already find the area of this rectangle, right? We just multiply length times width, 10 feet times 6 feet. Okay, so let's do that. So I'm going to say the area equals 10 feet times 6 feet equals, hopefully we all know, 10 times 6 is 60. And don't forget that anytime we're talking about area, your unit of measure is always squared. So we're going to call that square feet, right? So the area of rectangle 1 is 60 square feet. Now we need to find the area of rectangle 2, okay? So I know that this side measures 4 feet, but I do not know this top or bottom part. We're gonna have to find that out. That's a missing number, right? So I'm gonna say question mark. We don't know the measurement of this. This is where that trick about opposite sides being equal in rectangles comes into play, okay? So here's what we do know. I know that this top, this long line at the top measures 8 feet. And I know that this part here measures 6 feet. Now, if we try to imagine that this were one big rectangle, right? Maybe I can draw that in. Hold on. Right, I'm just gonna draw 2 more lines, which I will erase because it's not part of our problem. See, now we have one huge rectangle, right? But I'm missing this little red piece on the bottom. Well, I know the top is 8, and I know this part is 6. So what's the missing number? What is that missing number, right? Well, it's just 8 minus 6, right? To get that missing part, okay? All I would need to do is say 8 feet minus 6 feet equals 2 feet, right? So this little part here is going to be 2, which means this missing number right here with that question mark is going to be 2, okay? So let me erase some of this stuff because we don't want to get confused, okay? So we just found the missing number here, and that is 2 feet, okay? So now this small rectangle, rectangle 2, all I need to do again is multiply length times width to get the area. I don't have a lot of space in this small rectangle to write it, so I'm just gonna write it off to the side, okay? So I'm gonna say the area of rectangle 2 equals 4 feet times 2 feet. 4 times 2 is 8. And don't forget, we're talking about area, so we need to include squared in our measurement. So we say square feet. So we're not done yet. We're not done. The area of rectangle 1 is 60 feet. The area of rectangle 2 is 8 feet. But we need the area for this whole shape, this whole figure. So what do? Well, we just add the area of rectangle 1 plus the area of rectangle 2 will give us the total area, right? So all I need to do is say 60 square feet plus 8 square feet equals 60 plus 8 is 68. And don't forget to put square feet. Okay. And then we are done. That is our answer. Let me see if I can circle this. Oop. Still learning these tools, guys. Let me try that again. I got to start over here, right? Is that how it works? Well, never mind about that little circle. So this is our answer, right? 68 square feet. Okay, we're going to practice one more of these together. Okay, I made another composite figure for us to look at. Okay, this is a garden. You're going to see this later in your textbook, in the math book. Okay, so same idea. This is called a composite figure. The way it is right now, we do not know how to find the area of a shape like this. But we do have a magic tool. We're just going to take out our machete and we're going to chop and we're going to make rectangles because we definitely know how to find the area of a rectangle. So as long as we can get rectangles, it could be 2, it could be 3, then we can still find the area. Okay, so again, we have 2 choices of where we're going to chop. I could chop right here, or I could chop right here. Okay, it doesn't really matter that much either way. I think I'll do this one because it looks like this rectangle would be easy for me. I'm always looking for ways to make my life easier, but it doesn't really matter. You can do it either way. Okay, so I'm going to draw a line here. Same thing, I have rectangle 1 and rectangle 2. Okay, rectangle 1. Am I missing information or do I have enough information? Okay, looks like I already have enough information. One side measures 8 yards, the other side measures 10 yards. How do we find the area of a rectangle? We just multiply length times width, right? So the area of this rectangle area equals 8 times 10. And then let me move this down here. 8 times 10 is 80. 80 what? Square yards. Okay, so the area of this first rectangle measures 80 square yards. Then we need to find the area of the second rectangle. Are we missing any information? This time, no. We have all the information we need. This right side measures 12 yards. The bottom measures 8 yards, and I know the area of a rectangle is just length times width. So I just need to multiply 12 times 8, right? So I'm just going to say area equals 12 times 8. But hey, Mr. Auerbach, we never studied our times 12. We only did our flashcards up until times 10, right? What do? Well, some of you know your times 11 and times 12 anyway, but this would be a great time to practice, to review the distributive property. Do you guys remember that? Distributive property. That's when we take the bigger number and we break it apart, we decompose it into 2 smaller numbers, and then we distribute it. In other words, we're still multiplying both of the smaller numbers times 8. Okay, so I'm going to do this work on the bottom so I have a little more space to work with. So first I'm just going to write the problem. Area equals 12 times 8. Okay, but again, I don't want to multiply times 12. I don't know how to do that. It's confusing for me. It's a bigger number. So we're going to split up. We're going to decompose that 12. It's always up to you how you want to decompose. But we're always looking to make our life a little easier and not more complicated. We want to make our life less complicated, hopefully. We got enough problems in the world right now. We don't want to make more problems with math, right? So I like to always look for a 10. 10 is your friend in math. I like to look for a 5. Of course, 1s are easy, 2s are easy. So I'm going to decompose the 12 into a 10 and a 2. If you want to decompose it differently, fine. You could do a 6 and a 6, 7 and a 5, 8 and a 4, etc. But again, I always want to look for a 10 because 10 is my friend. Okay, so, oh, I thought I was still in the same one. I guess not. It's okay. So I'm going to say 12 times 8 equals, remember, this is when we use those parentheses, right? So I'm decomposing my 12 into a 10 and a 2, right? So I'm going to say 10 times, we still need to multiply by 8, right? Plus, you guys remember the distributive property? I know it's been a little while, but we spent a long time working with this, right? When we were back in school. So I did 10 times 8, and I still need the 2 from the 12. So now I do 2 times 8. Okay, and then I just do them separately, right? 10 times 8. Normally I do this on the bottom. I'm not so skilled with all the Zoom annotation tools yet, so I'm just going to keep going right and left. So 10 times 8 is 80, plus 2 times 8 is 16. And then we add them together. 80 plus 16 is 96. Why did they? Oh, there we go. I can stretch it out. Okay, is 96. Okay, so that is the area of this second rectangle. So I'm going to go back over here. And we're going to say area equals 96. Don't forget square yards. Okay, the area of the first rectangle was 80. The area of the second rectangle was 96. Are we done? Are we done? Are we done? Not quite. Almost, but not quite. Then we still need to add them together, right? So 80 square yards plus 96 square yards will give us the area, the total area of this composite figure, right? So I'm just gonna say 80 square yards plus 96 square yards. And if you don't want to do the mental math in your head, right, you can rewrite it up and down vertically using the standard algorithm. That's fine. Or some of you are already good at your mental math, right? And you're going to say 176. Is that right? 96 is almost 100, right? 4 to get 100, 176 square yards, okay? So this is my answer. This 176 square yards is the area, the total area of this entire composite figure. Okay. So let me just turn my screen share off. Okay, so that's the end of our lesson, the end of our little demo. You guys, of course, will be practicing some of this on your own. I look forward to reviewing your work and hopefully getting the chance to give you some helpful feedback. I miss you guys. The school year's almost over. Can you believe it? I wish we were in person so we could celebrate and give high fives and hugs and have a little dance party on top of the chairs and tables. But we'll just do the best we can. I miss you guys. Okay, talk to you soon.